So we are going to start with the univariate analysis, or what I'm calling predicting a house price. House price just using one variable. And we are going to have a sample. We have a sample problem here of predicting home price in Monroe, that is New Jersey, USA. And the problem statement here is given the above data set, build a machine learning model that can predict home prices based on square feet. This is the example that I want us to use first, so that we can see how you can use these models to even do some prediction. So I'll just have to upload my data set here. I think I have a sample data set here. This is the data set that we are going to use. Let me load it. Okay, as I'm loading this data set, okay, can someone just tell us, maybe you can give us examples of variables that can be used to predict a house prices. Can be in Kenya or in any other country. What are some of the variables that determines house price? You can just unmute and tell us. Yeah, let me see that. That is Tuuze Bidhaa. I can see Tuuze Bidhaa saying location, size. What else? Someone talking of neighborhood, demographics. Okay, continue listing them. Yeah, we can see someone say costing of the building materials, uh, the crime rate in the area. That is, I think, is the same as the security. Yeah, in fact, these are some of the variables that can be used to determine house pricing in any area. So I want us to use, in this case, I just want us to use the size. That is the size in which that house is built, and we are going to calculate the size in all the size of the size of that house is measured in square feet area. And we are going to use a very common equation, that is equation of a straight, is it an equation of a straight line where we have this, let me just remind you this equation before we get into this. Can you guys remember the equation of a line? What was it? Someone to remind us in the in-call messages. It was y is equals to,
mx plus c.
yeah, mx plus c. Thank you. That is mx plus c. So for linear regression model, it uses this equation. Hereby we are going to have the y as the home price. We are going to have that is the m x X in this case is the area, and C is always the constant, right? So this is the equation that you're going to use in the linear regression model. It isn't different from the one we did in high school. So, and the first thing that we always do anytime you are given such a program is to import the to import the libraries that you're going to use. In this case, we must use pandas because we need to upload data. I mean, we need to read the CSV file. Again, you are going to use NumPy because we are dealing with numbers here, and we are going to import the linear model from this repository. That is from the sklearn repository. Then uh, then maybe we are going maybe to we can plot, but I don't think in this case. But we are going to plot. That is the reason why we're using the matplotlib .pyplot. They are importing that as PLT. I think by now you are familiar with these libraries. So the first step is always this. So I think I can label this as the first step to predicting house prices using uh, a model here, a machine learning model. So this is step one. So after importing this, you can just run this. Then the second step is now to read our data set here. That is, this is the step two. That is, in fact, you can see loading the data set. Step one is importing, just copy this. Importing of that is libraries. So after, I think you can just read this by copying the path here, and then we just place it in between these opening and closing speech box. But in this case, we're using single quotes. So that is the df and then pd.read, and then we just copy paste the path for our data set here. So if we just maybe run this, we should be able to get the first five rows of our data set. You can see that we have the area and we have the price. Rodavan, is it a question?
Do you hear me?
Yes,
Are
please.
you in a position to share the data sets in the
Sorry?
WhatsApp group? To share the data set which you are using at the moment?
Oh, I did share this. I think I can share it right now. I will let me share this very fast. I thought I shared this data set. I think I'm growing old. I thought I shared this data set. Let me share. Just a minute. That is the data set we're using. Have you seen the data set? Just confirm that you have seen the data set. Good. Those are the two data sets that we are going to use. So you can as well as read it. And I'm hoping that you guys are able to see my screen as well. Can someone confirm? Are you able to see my screen? Okay, good. So this is the data set that we are going to use here. That is a data set with the area and the price column. In fact, this data set has let's check the shape of this data set. You can see it just have like five rows of data and two columns. I think you can also remember how we were checking the shape of our data set by using the shape, that is the shape attribute. So this is the data set that we have. Oops. That is the head. If you read the head, we are just going to read the whole data set here. So this is the data set that we have. Let's just study this data set, and you can see that we have an area where we have an area of 26 square feet that costs at 550,000. I think this one is in US dollars because we are dealing with a data set from that is Monroe, New Jersey, USA. So we are seeing that a house of that 2600 square feet area, it's costing us 550,000 US dollars. A house of 3,000 square feet, it's costing about that is 565,000. You can notice that we have an increase, maybe by that is 15,000. Is it 15,000? Yeah. When we get into 3,200 here, we can see again we have an increase by some figure here because now this house cost that is 62 that is no 610,000 US dollars. So and the trend continues. I think you can already master. We have a trend here. Anytime we increase the area in square feet, the price increases. So with this kind of data, it's quite easy to see the pattern. That anytime that we increase the area of the house, then the price increases. So this is just a simple data set, just using the area to determine the price of a house. And now with these, we can use now the equation that I was saying. That is the mx. That is the mx plus c. That is the equation of a straight line. In fact, it is quite easy, even how we are going to implement this model. So from this, we can just try maybe let's just try to draw a scatter plot for this data, so that we can see how the price is how the that is the area against the prices that is it is distributed. So we can as well as have the PLT dot the X label that is on the X-axis. We can have Y label at the Y-axis. Then we just plot we just use the PLT dot scatter. With this, we just have to pass the data set here. That is the df dot area and the df dot price, and maybe we can use the color red for the dots. In fact, we have just identified, we have specified the marker that we want to use. It's a plus sign. So this is the plot that we are getting here. And you can see most of the data points here. They are quite linear. All they lies in a straight line here. I think it's just one data point that is missing. This data point here, but you can see the majority of data points are they are quite like making a straight line here. So just from these, we're able to visualize how the data is distributed, and now it will be easy for us even to implement this model. In fact, with this data set, we don't have to do any cleaning, because you can see that our data is already clean. We don't have any missing values. We don't have any missing values here. At least we have all the rows with two. We have all the columns with the data set. So in this case, we don't have even to do any cleaning of the data set. So, but remember, this one is just a sample data set. So let's just get into how you can now create a model that will help us predict the house price based on the data that we have. So the first thing that you are going to do here is to separate these columns. And the first, when we separate these, we are going first to have the price column on its own, and then we are going to have the price on that is we are going to have the area. This is the area on its own, and then the price on the price is as an independent column. So we are going to have a new df is equals to the df.drop, and you can see we are dropping the price column, meaning that you are going to be left with the area column. It's always good to specify that you want to the price is it's on axis columns. It's always good to indicate this anytime you are trying to draw the column names. So with the new df, we have our area data, and then we can have price is equals to df dot price, simply because we dropped the area, and that is why you can see that price is equals to df dot price. And even when you try to print out the price part, we have the prices now. So the last part of creating the model here is creating something you call creating an instance of our model. I think you can see that in here we imported the linear model. So with this linear model, this is the model that we are going to use. It's simply imported from sklearn. And we are going now to create an instance of, because our data is ready, we are just going to create an instance of that model. And in fact, we can just call it, I think I can change this one to something like linear model. Oops. Let's change this to linear model. That is linear model. That is linear underscore model is equals to, that is now the linear model that we imported. And the model that we want to use is the one that is called linear regression model. You can see that this model resides in this repository. That is the linear underscore model that is now from sklearn. So with just this line of code, we have created an instance of the linear regression model. It is just that easy. So we can as well as change this one to linear model. And now I can use this linear model to train. Let me just indicate here that I'm training the model. So this is how we train the model. You just have to invoke the instance of this model, and then we have the fit method that is going to help us to train the model. So that is now the linear underscore model dot fit, and then we are going to pass uh, that is the area, that is the area of the data set that we have, and we pass the price. In fact, this function here just take two. This function usually take two parameters. That is two parameters. It takes two parameters. That is our dependent and independent variables here. So now when we run these, oops, I can see we have a problem here. We are told that sklearn model has no attribute fit. Let me just counter check this. Linear model. Let's just use this model. You can just use model because I think it is yes, let's just use model to avoid the conflict between the actual repository and the name of the variable here. I think we can just run these. Oops. I think we didn't run these. And also these. Then we can just run these. And by just running these two lines of code, that is the creating the instance of the linear regression model and training our model using the fit method. We have a train model here. So this is our train model, and by the way, now we can maybe try and predict. We can maybe try to predict the price of a home with an area of 33. That is 3,300 square feet. You notice that we don't have. Yeah, we don't have an area here with 3,300 square feet. You notice that it should be the value or the price of that house should be somewhere in between. That is somewhere in between. That is 61, 610,000 and 680,000. Because it is not more. It is in between. That is 3,000. I mean that 200 and that 600. So the value that we expect here, it's a value that doesn't exceed, doesn't go below, that is 610,000. It doesn't go above what? Doesn't go above 680,000 because it's 33. It's 33. Let's get into this graph here. It's just like somewhere here. So if you were to draw the line of the best fit, let me show you something before we do the prediction. You can see, good. So if you were to draw the line of best fit here, you notice that these data point, and this data point, as well as these, I think they will be on a line, right? So, and just using now this plot here, if you were to draw the line of best fit here, we can even predict the cost of a house with an area of 3,300 square feet, because we can just position, we can maybe just try to say that that 3 lies in between between 3,200 and 34. So maybe somewhere like here. And now we can just try to join that with the line of the best fit, and then we check the price here. But because now we have our model train, we can just use the model.predict function here. Let me just try this well. We have model.predict, and then we have now to pass that value that we want to predict. So if you happen to run this, you can see that you are getting a value of this is 62. This is 628,715. Let's check that here. This is the value that we are getting. That is 628. And you notice that 628 is somewhere in between 610 and 680, right? And the 610 and 680 is the what? They are the prices of houses in between. That is 200 and 600. So you notice that our model is I think I'm assuming that it has predicted right. This is the price of house. I think I've seen someone raised a hand. Radovan, any question?
So here on the model.predict, where have you used the double squares on the 3, is it 3,000?
Sorry, I can't hear you.
Okay, can you hear me at the moment? I don't know.
With this one?
Yeah. On the 33, on the 3,300, where have you used the double bracket?
Of the double square brackets here.
Yeah.
It's because I'm trying to pass up. This is an array. In fact, this is the value that you are trying to pass here, right? Let me just cut that. But you notice that this is just a DF with one point, right? The first one is for the data frame here, and the second one is a list, not an array, a list with just one data point. Maybe you are just to pass 33 here. You notice that you are going to get an error here. Let's see the error that you are getting here. I'm hoping you're able to. You notice that we are expecting a 2D array, but you got a 1D array. But even the reason why we are seeing this is because the first bracket here will be for the DF. That is the DF with one just 1 point one data point here. That is why it looks like now 2D. If you guys, you can remember how you are defining a 2D array or how you are creating a 2D array is by using you are using two square bracket. In fact, that is the reason. The first one just pick the first square stuff is for the DF. Then second one now will pick the actual value. So that is when it's disabling a 2D array. I think we are we together on that one.
Yeah, perfect.
Sorry?
I got it.
Yeah. So any other question? Let me just try to rerun this. Let's just try to use a value that is already in that in our training data set. So we can just try to use a 3000. Let's just try to predict a house with an area of 3000 square feet. So let's run this. And you can see we are getting a value of that is 50. Let me just copy this so that we can compare it with we can compare it here. Let's see this. We have this value, and we have this value here. So let me just try to check the difference here. Let's copy these, and we can print the difference. And we can see that the difference is that is 22,000. This one could be caused by many reasons. Maybe we can just try to check the that is the score, that is the accuracy score of this model. Let me just try to do that very fast. Let's see if you're able to check the model, this model accuracy score. Shouldn't get that huge difference. I've used the model. This is, let me just copy this. Model.score. Maybe let me just try to check in the accuracy. The model here. Should be model here. So we can have, that is the model.score. Let's just try to, oops. Let me see this, the score missing two required position argument, that is the value of x and y. So let me just pass these two values here. that is 3000, and this value that you are getting in here. So let me just copy this. Just a minute. This should be 2D array as well. Oops. We just have, let me see this. If there is another way we can check this, that is accuracy score. Let me just try this model.accuracy score. Oops. Am I forgetting this? Yeah, let me just confirm that. There should be something to do with model.score. Let me see the options that we have here. Let me see this. Let's see this. Who is the hand? I see someone's hand is up. I think someone is saying we use the new df. Let's see this. We are supposed to pass just one value. Let me use this. I think we have a score of that is 95.8. Why are we getting such a huge difference? Let me just try to predict again. I think we should have that huge difference. But we can as well maybe try to use we can just try to maybe to check using the equation. That is the y is equals to mx. So we can just maybe try to use the coef. We have the something called the coef to find the coefficient. So let me just show you that. And the y-intercept. It's very easy. That is, we can just use the model dot the coef to find the coefficient that is used in this equation. And we can also use the model.intercept underscore to find the intercept, the y-intercept that is used again in this in this equation. Then we use the m that is the mx plus b, where m is the coefficient and b is the intercept. Maybe when we try to use these, we are supposed to get the same value as the one that we try to predict here using the model. I think that is the best way to now to find the difference between the model and using the equation here. So let's predict these. And when you predict using the model, that is the machine learning model here, we are getting this value. That is 628, 715. But what about when we use just our equation? Where we are taking that is that 300, we multiply by our coefficient, which is we have seen that it is it 135, 135 dot 0.76 7876 7123 plus our b, which is our intercept here. So when we run these, we are getting a value that is almost similar to what we got from the model. I think that is the best way we can use to verify that the model is giving us the right output compared to what we are getting from our equation here. That is mx plus b. So I don't know if there is any question with the implementation of these. Let me just try to oops. To predict another one here. Just a copy. And now when you predict maybe for the 5,000, if you were to change maybe these to 5,000 here, just to verify that our model is working fine, let me just run these. And now you notice that the output we are getting in here and the output we are getting from the model, they are quite similar. If you were to check maybe the difference between this one and this one is just something small. You can do that with print. Let's just try to check the difference here. Let me copy this. We minus the value from our equation. Let's see this. And you're getting that we are getting a very small value of 1.4385674. So that is how you can verify that your model is giving you it's giving you same or almost same value with your equation. So any question? Do you have any question? Yes.
So in this linear equation model, is it tied up to two columns? Can you have more variables, like 5 variables to the equation?
That is to predict the cost of a house.
Yeah. For example, the area, the amenities,
Yeah.
the location.
Yes. Yes, that one is possible. In fact, that is the next thing that you're going to check, where we're using more than one dependent variables. Yeah, that is again now to predict the price of a house. That is the next example you're going to have. But do we have any example with the implementation of the model using one variable? Okay, thumbs up if you are together. If you guys understood that. Okay, who feels that maybe we should repeat that? Who thinks that we should maybe try to but you can see most of us are okay with the model. Okay, can you put your hand up if you're okay with the linear regression model implementation? Mary, are you okay with the model?
Yeah, yeah.
So let's get into, you notice that this one is not an ideal case, whereby you just predict the price of houses in one variable, right? But I want us to see how you can use maybe multiple variables. We are going to check. In this case, we're just going to use. There is a data set that I've shared also on the WhatsApp, uh, and there is a data set that I'm going to upload here. Let me see this. Let me just upload it. That is the one on home price too. I think I've shared that data set on WhatsApp. You can load that one as well, and also import the required libraries. I think you guys are familiar with that now, and then we just have to import that data set. And you guys know how to do it. You can just copy path and paste it here. Oops, I can say I have a problem here. I think it's because I have not run this cell. Let's wait for it. Good. Maybe I can just check the shape of this data set. I can see it just have like six rows of data and 4 columns. Let me just use the df now to display that data set. So you notice that in this case now, we have how many variables? We have like three variables that are going to be used to determine the price of this house. That is the area at which the house is built, the number of bedrooms, the age of the house. And by the way, if you are using maybe a large data set, we can even change I think you can remember how we were changing the column names, maybe to use names that make sense. Like we could maybe change this one to the number of bedrooms, this one to maybe something to age of the house, yeah, so that it can make sense. So, but in this case, we're just going to use it as you're going to use is you're going to just to use it the way it is. And you can see that when we come to the area column here, again we don't have null values. But now when we come to the bedrooms here, we are seeing that there is a value here that we are missing, but the rest are okay. So anytime you are given the data set, before even you try to use the model to do any prediction, it's always good to the first step is always to clean that data set. Like in this case, we are going to replace this value by using the median of this column. And if you guys you can remember how we were calculating the median, we have a median function again in pandas to calculate the median of a certain of a certain column. So in this case, we're just going to use the df dot bedrooms and then the median. And if you were to run these, you notice the median is 4.0. So the first thing that we are going to do before we use this data set uh, in our model is to replace these. And you guys, you can remember how we were doing that using the fill method. We just have like to have the df dot bedrooms. This one is just to mean that we are just replacing the value at the bedrooms column. That is why we're using df dot bedrooms is equals to df dot bedrooms, and then we are using the fill null method. And in fact, this one we can change this one to, we can assign this one to a variable. Maybe we can call it bedroom underscore. Let me just copy this very fast. You can just use this. That is copy. Oops. Yes, I think you can just assign it to a variable, and then that variable we can just use it here. That is now the bedrooms underscore median. So just the same as having the whole logic here. So let me just run these and now these. And now you notice that in our data set here, the one that we have, we don't have any missing value in this column because we have used the fill now method to fill that one with a median. So now from here we can just proceed. And to proceed is just by we proceed by creating an instance of the linear regression model. I think you can just rename this one to let's call this model. This is model. Copy these and use it here. So we have model is equals, first we create the instance, that is model is equals to linear underscore model dot linear regression, and then we train now our model. You notice that we are using df dot drop price, that is on the axis column, so that now we can have all the dependent all the dependent variables here. That is now the area, bedroom, and age, and then we just pass our price here. So if we run these, we have now a train model. The reason it is it's quite fast is because we're using just dummy data here of just 6 columns. So after that, we're able to get our train model, and then we can just maybe try to run these so that we can get our coefficients here. In this case, we are going to have 3 coefficients, simply because now we are using three variables to determine the price of the house. So we are going to have 3 coefficients, but the intercept is always 1, right? So we can just run these again just to so that you can see that we are getting 3 coefficients, and then we have our intercept here. I think we should change this one to model model.intercept, and you can see that we are getting just one intercept. So this is now this is the array that is this is the array of intercept, the coefficients that are used by the model, to determine to predict the price, and this is also the y-intercept that is used to predict the price. So I think we can now maybe try to find the price of a home with these given values here. That is a home with 3,000 square feet area, a 3-bedroom, and that is 40 years old. So again, that one we're going to pass it as a 2D array. So that is, let me change this one to model. And if I run these, you notice that you are getting the prediction here. That a house with these variables, it will cost us, that is 498,408. So if now you are maybe to check that, if you were to check that using the equation, we should have something like these. That is maybe the price is equals to, guess here we have just this is M1 should be, let me copy this. Let me show you the equation of how this equation looks like. So we have M1, we multiply by X1 plus M2. You can just copy this. This is M2. We will multiply by X2 plus let me, you can just copy this. That is M3 plus X3 should be X3 plus now the coefficient here, or the constant. So this is the equation that that is going us to give us the prediction, and you can see that we have the three coefficients that we are going to use. So if maybe we try to run this, we should get a value that is almost the same as the one that is predicted by the model. And you can as well as check the difference between the model prediction and the equation prediction. So we can maybe try to do a print here. You should just try to verify this. Let me copy this, copy. This, let's see. You notice again we are getting just a small value here of that is negative 6.2861. So you notice that the value that you are getting from the model and the value that you are getting from equation, they are almost the same. In fact, they are varying with just a small value. So I don't know if there is any question regarding how we can predict price of a house using multiple variables. Any question? Okay, thumbs up if you guys have understood that. Yeah, I can see Carl, I can see Joseph, I can see Stu, Zebida, Meritika, Mombi. Yeah, what about the rest? Rodavan? Yeah, I can see also Rodavan is okay. Kezia, are you okay with how you can predict using multiple variables? Yeah, I can see most of us are okay. So you can see how simple it is to implement a linear regression model. That is on univariate and multivariate cases. So I think that is it. That is it. In fact, it is just that easy. And I would like us maybe to, in case In fact, if you get into Colab here, I need you to try out something else, something here. If you were just to maybe let's try to read this data set. That is on the California underscore housing underscore train dataset. So let us just maybe try to read that dataset very fast. Maybe I can change this. Let me just try to read this. This one is a large dataset. Maybe I should try to print the head. Let me just try to read the head of this dataset. You can see that with this dataset here, we have so many variables that are used to determine the house of to determine the price of a house. We have the longitude and latitude, that is to determine uh, the location of the house. We have things like the housing underscore median underscore age. We have the total rooms and we have total bedrooms. We have the population in the area. You can check and see households. I think Rodovan said this. Is it Rodovan or Tuzebida? I think someone said the households. You can also check the median of the income that is on the people living in that area. You can see, let me just try to check the shape of this data set. Um, you notice that we have like 9 columns. That is -1. Maybe we can say eight columns that are used to eight columns of variables that are used to determine the price of the house. And you can see that we have quite a large number of entries. That is about 17. That is 17,000. You can just try to use this data set and you know that the more you feed a large data set into your model, the more it will be accurate. So if you were to use maybe this data set after cleaning this, let's see this df dot is let me see this nav dot this is the sum. Let me just copy that. Should be a function. Am I missing something here? Supposed to be is null, not null. You can use is null. Let me see this. Oops. Are we getting these? Let's check this very fast. Copy the code. That is not the sum. This is the function that we use, because you can just confirm that. Is it a function? Yeah, it should be a function. Oops. What is the problem here? I think I was writing the is as should be a function. I think still this data set doesn't have null values. Maybe you should go to Cargo and check for datasets that have that need some cleaning, so that at least you can do some cleaning. You do some cleaning before you use the dataset in your training. That is removing null values, fixing some missing values also, like that, so that now you can now use that data set in the model. But just try to make use of these data sets that we are provided with. That is the California underscore housing underscore train to train your model, and you can as well as use the test these data set also to test your model, so that you can maybe that is something that you can do overnight, so that now tomorrow, I think tomorrow we're going to check a different model. Now that you've understood the linear regression model, tomorrow you're going to check an SVM. We see again how SVM is used to how SVM is used in machine learning. So I think that is it. I don't know if there is any question regarding this linear regression model. Do you have any question? Okay, thumbs up if you are okay with the model. Yeah, I think most of us are okay with this model. Yeah, so I think we can call it a day. Let's meet tomorrow to check a different model. Yeah, I think tomorrow we can check. Yeah, tomorrow we can check SVM and we see how it is used. That is in machine learning. So why don't we guys meet tomorrow? Let's